Welcome. Today is a concept-based class. See, I'll first tell what is it. Angle of inclination for a rough inclined plane when a body freely placed on the inclined plane to be on the verge of sliding down. Or this can be told in some other way also. I'll explain. I'll dictate. See, I will dictate, you should write. But before I dictate, I will tell what we are going to do. Correctly see. Those who want serious understanding or full understanding, what all I explain you should write. See, you consider a plane. See, horizontal plane. Place a body on it. Sliding, nothing is there. It will rest freely. See, freely. See, the word freely is very important. Means no other, only weight of the body. You should not apply any forces like that. Freely placed. See here. This is in equilibrium. There is no question of moving. If you want to move, you have to apply a force. Okay, now you place this way. Now see, this I told yesterday. Slowly increase the angle. See, make it inclined. See now, you can see the block, that body is still at rest. It is not sliding down. See, I will increase further. Yes, still it is, see, it is still stationary or at rest. See, you can see there. Suddenly, it started sliding down. See, sliding down. That angle of inclination with the horizontal, we want it. Why horizontal? Because, see, everywhere, when you go either up or down in a road, angle is considered with horizontal. Because gravity is vertically down. Okay, now, or I will tell some other way now. See, again to understand, go through it, listen and write. This I told yesterday, once again. Imagine a flat road. You take an object or a vehicle, heavy vehicle, a truck or a car. But remember, brakes are applied. Very important, brakes are applied. So that wheels cannot roll, it has to only slide. Now, imagine a truck or car, okay, truck only, is resting on a horizontal plane. Nothing, see, over. Now, let it be resting on an inclined plane. See, this way. See, brakes are applied. See, when brakes are applied, it cannot roll, it has to slide. See, now, the weight of the body will have a component along the inclined plane, which will try to slide it down. But friction is there. Because of friction, still it is not sliding down. See, now slowly increase the angle. Those who are in the vehicle will have tension now. See, those who are actually how to increase the angle. Imagine arrangement. Okay, imagine road becomes more stiff. See now. See, started sliding down. Yes. That is the angle theta. Or we want to find that theta. See, this theta. When the body placed is on the verge of sliding down, freely placed, that is no other extra forces. Or, see, for example, suppose theta equal to 0 degrees, then no sliding. Suppose theta equal to 10 degrees. Imagine still no sliding. No sliding. Suppose theta equal to, see, little this way, 20 degrees. Still no sliding. Imagine. Still no sliding. Theta equal to 21.5 degrees. Still no sliding. We will go for second decimal accuracy. Theta equal to 21.559 degrees. Still imagine no sliding. Imagine theta equal to 21.60 degrees, yes, on the verge of sliding. On the verge of sliding. Imagine on the verge of sliding. 1 minute now, I'll check the camera first. Because I reduced the size of the board. See, on the verge of sliding. Imagine how much? 21.6 degrees. Therefore, if the angle is 0 degree up to 21.6 degrees, the body will be at rest. See, no sliding means rest or equilibrium. Nothing, no effect, nothing, no sliding. Vehicle will remain there only. Now, when theta is 21.6 degrees, imagine 21.6 degrees, suddenly, slowly, it starts rolling, sliding down. So, if your angle is anything above, above 0, up to 21.6 degrees, the body or vehicle will not slide down. But when it is 21.6 degrees, it will not slide down, it is on the verge of sliding down. Little more angle, 21.61 degrees, it will start sliding down. Therefore, this 21.6 degree is the angle made by the inclined plane with rough inclined plane with horizontal when the body is on the verge of sliding down. Or you can write here, this I already told, or you can also tell one more thing. We are finding, see, the maximum. It is a maximum. Why maximum? Because limit is there. See, as you increase the angle, maximum limit. If you exceed the limit, see, it is a maximum limit. See here, maximum limit. Okay. See, it is moving now. Increase it, it will slide down. So it is the, some people, they call this as the maximum. I will dictate now, you should write it, or maximum angle of inclination of the rough horizontal plane, rough inclined plane with horizontal, up to which the body will be at rest. Means there is no sliding. Maximum limit is 21.6 degrees here. Actually, this for example. You write all these things and make a full note. See, these are all called concept. If these concepts are clear, subject becomes more clear. Okay, now I will remove this one now. The statement I will remove. Okay, see what I am doing now. Okay, now start. We want to find that angle when the body is on the verge of sliding down. Okay. Consider a body of weight W. Actually, it is independent of weight W. But remember, depends on friction coefficient. Very important. See, as the roughness, you can make a note. As surface becomes more and more smooth, it will easily slide at a lesser angle. As the surface is rough and rough, or as the contact surface becomes more and more rough, then friction will be increasing, so it can sustain higher angle. So anyway, you write W. Later you can make out W will vanish. Okay. Consider a body of weight W freely placed. Very important. See, I told freely placed. The word freely placed means with no other extra forces. See, no one should go and prevent it. No one should apply a force. Free, see, I told you, freely placed. Freely placed on an rough inclined plane with angle of inclination theta with horizontal. See, as shown, see, this is a rough inclined plane, a body of weight W is placed here, angle theta with horizontal. Then, let the body be on the verge of sliding down. Very important, because our discussion is when the body is on the verge of sliding down. Okay. Now, let mu be coefficient of friction for the contact surface of the body with the inclined plane. For this contact surface, let mu be coefficient of friction. Now, red color I wrote, since the body is on the verge of sliding down, the resisting frictional force Ff will reach limiting static frictional force, that is Ff limit. This I will not tell because it is told more than 100 times. Whenever a body is on the verge of moving, either horizontally or inclined plane, whatever it is, when it's on the verge of moving, the frictional force is called limiting static frictional force Ff limit. Then write here. See further. I will use red color for unknowns today. Okay. Okay, red color means no. I will use full black only. Okay. Let R be normal reaction. Normal reaction, you write here. You continue. Normal reaction on the body from the contact surface. You should write. Then we know that Ff limit, limiting frictional force, equal to mu into normal reaction R. Already more than 100 times it is explained. See, Ff limit equal to mu R. If the body is stationary, then Ff is not equal to Ff limit. It will be less than mu R. So I told you the limiting Ff limit will be equal to mu into R. Right, let R direction, right. Now you write a neat sketch. Neat sketch. I will write a sketch here. Okay, I will write a sketch here. Then see. Anything else? No. I will put a mark here up to where I can go. Okay. This all I told you. I am removing it now. One neat sketch I will write now to understand the concept. See here. This is the inclined plane. Inclined plane, rough inclined plane. I won't write once again because I already wrote here rough inclined plane. This is the body, somewhere placed here. This is center of gravity. Through this, the weight will act vertically down. See here? Vertically down. It became, when I write here, see, weight will always act vertically down. You should know that much. Okay. Okay, now this is weight W. Then, since it is sliding down, see, sliding down, normal reaction will be slightly this side. Anyway, I told you, does not matter. This is the normal reaction R. Perpendicular to the plane. See, perpendicular to the plane. Then, you make a note. You should write. See, you should write here. The body, you write here, the body is on the verge of sliding down the plane. So frictional force which will oppose the motion will be what? Not down the plane, along up the plane. So your frictional force Ff limit, I'll put red color. Sorry. This is Ff limit equal to mu into R. It is this way. See, when the body is going down, it is up, and this angle is theta. See? This angle is theta. This theta you have to find. Okay, now I will remove everything and derive equation or expression for theta. Actually, remember, your theta will come equal to phi. Means this angle of inclination is equal to angle of friction. Then I will explain something else for you. Okay, 1 minute. I will prepare sketches. Now, correctly understand. See, first write the sketch here. See, make a note here. Here, x, y, y are not there. This is our arrangement. See, you write the sketch here. I told final sketch here. I told already. See, weight acting vertically down, angle is theta. This is a reaction, normal reaction. This is a frictional force, mu r limit. This is general. Now, this is the reference now. See, class. I told earlier, whenever you should write what all I dictate you ought write. Whenever inclined plane problems are there, and at a time, if you are considering only one inclined plane, it is advantageous to consider xx along the plane, yy perpendicular to the plane. So many places it is advantageous, and it is usual practice also everywhere. So right here, usually in engineering mechanics up to now, we considered xx horizontal, yy vertical. But when you get inclined plane questions in friction or later sometime, see, when you go for radial shear and normal thrust also it comes, be careful in arches in structural analysis. Then what we will do here? We will, best option is along the plane xx perpendicular yy. Actually last class thoroughly explained. See, okay, now that is usual data class, usual practice. It has got advantage, but remember that advantage is only when there is one inclined plane at a time. But at a time, if two inclined plane comes, it will come later for wedge friction or some other question. If two inclined plane comes, no, then don't go for it. Then see, what happens? If there are two inclined planes, xx, you cannot take two xx, only one xx. In such cases, you drop the idea of xx along the plane, yy perpendicular. When multiple inclined planes are there, then you take xx horizontal, yy vertical. So only when one inclined plane, here only one inclined plane is there, it is ideal to get. Now, right here, option 1, class, once again class. Once again I will tell class. Something I will tell in the class now. Class. Option 1, what we will do is, this advantage I told, or the popular version of considering xx along the plane, yy perpendicular, we will not do it. We will go for our usual pattern, usual so far. Usual so far is xx and yy, xx horizontal, yy vertical. But remember, it is only for understanding. See, only purpose of understanding. And right, understanding. But next time onwards, when you consider inclined plane cases with only one inclined plane, remember, not multiple, with only one inclined plane, we will always consider xx along the plane, yy perpendicular plane. But anyway, for understanding purpose, what we will do? Option 1, we will take, see, xx horizontal, yy vertical. So your option 1 is only for understanding. Later, we are not doing it unless there are multiple inclined planes. Okay, now start. And then write option 2. See, I wrote big here. Option 2 is the most popular. Most popular and also everywhere considered. Any textbook, anywhere you see, when one inclined plane is there, people always go for this one, xx along the inclined plane, yy perpendicular. Class, this is the most important. Right means next time after today's class over, next class onwards, when we consider inclined planes, of course one inclined plane, we will always consider xx along the plane, yy perpendicular to the plane. This we will not consider. So this is only for understanding. Okay, you write all these things right now. Option 1, cut means what? No, it is only for understanding, otherwise not required. See, this question, it does not matter. Both the ways you get easy answer. You can make out later the advantage of option 2. So after today's class, we will always consider option 2 right here. After today's class, we will always consider option 2. Okay, start. Option 1. Let us consider reference axis xx, yy. x horizontal, y vertical. Okay, now see, put the sketch. See here, block, weight acting vertically down, normal reaction perpendicular to the plane. This you know it already. See, normal reaction is perpendicular to the plane. Okay, I should not write here. How many times I have to tell it? Perpendicular to the plane and frictional force along the plane. And remember, only this time our reference is xx and yy. Therefore, what you do is consider angle with the xx. With the xx. This I told you, with the xx. That is horizontal. Horizontal. Then horizontal component is cos, vertical component is sine. You know it. Okay, start now. See. This is purely vertical, W, leave it. Now see, normal reaction this way. If this is theta, this is 90 degrees, this angle is, see, 90 minus theta. When this is 90 minus theta, see, this angle, when it is 90 minus theta, when you resolve, see, this way, horizontal component is left side. You should write correctly, see, for this one, okay. Horizontal component is left side and vertical component is upward. Horizontal is cos, vertical is sine with respect to this angle. See, angle should be with horizontal. I told you, only when you consider the angle with horizontal, horizontal is cos, vertical is sine. Here, FF is this way. If this is theta, this also theta. See here, it has got a, I'll put here, small letters. Theta, little bigger I'll put here to understand. See, to make clear, little bigger sketch. Okay. FF limit equal to mu into r. Then, see here, when it is going this way, theta, this is cos, this is sine. Horizontally right side, vertically up. Horizontally left side, vertically up. These all you should know it. Okay, now remember this cos sine is based on this angle with horizontal. See, when you write horizontal cos, vertical sine, first of all I am wasting my time. This is told thousands of times earlier. So when you write horizontal as cos, xx as cos, vertical as sine, the angle should be with horizontal or xx. Okay, start now. First make usual sigma Fy equal to 0. See what happens. Usually in all the friction problem, best is sigma Fy 0 first. Sigma Fy 0, take upward positive. See here. This way. Plus r sine, okay, I want to use color now. Plus r sine of 90 minus theta. See, plus r sine 90 minus theta minus w, see, minus w, then plus mu r into sine of theta equal to 0. You call this as equation number 1. You call this as equation number 1. Okay, then sigma fx equal to 0. Take right side positive. See here. Right here, right side positive. You get, see, minus r cos 90 minus theta. See, minus r cos 90 minus theta. Then, this way over now, left side. This is purely vertical. Then, plus mu r into cos theta. See, minus r cos of 90 minus theta plus mu r into cos theta equal to 0. I got a doubt about the board. Have I gone beyond the limit? Because I think no. Otherwise I should turn the camera slightly. No, it is okay. Okay, now do one thing. Our purpose is to find theta, correct? This is equation here. Do one thing, continue. See, R will cancel. Your R and R will cancel. Or you get minus of cos 90 minus theta is sin theta. That much mathematical knowledge should be there. Cos of 90 minus theta sin theta plus mu into cos theta equal to 0, or see, mu cos theta equal to sin theta. See here, mu cos theta equal to sin theta, or sin theta by cos theta equal to mu. But we know that sin theta by cos theta is tan theta. That is tan theta equal to mu, or your theta equal to, answer I will write now, your theta equal to tan inverse of mu. This is the answer. Oh, your equation 1 is of no use. We want to get theta, we got it. This is useless. Okay, write it. So we got theta equal to tan inverse mu. I will write here. See, note. By option 1, see, I write here. Black color. Actually, no, black color I write. Option 1, we got theta equal to tan inverse of mu. Okay, that's all we want. Theta is coming in terms of mu. Okay, this is option 1. Now do one thing, continue, little more statements are there. We'll do one thing, we'll first go to option 2. Option 2. Hope that even in option 2 also, we will get theta equal to tan inverse mu. If this is not coming, then I do not know subject. I do not know anything about subject. I do not know teaching. I will stop my class today. If answer is not coming, it will come. Okay, but I will do one thing, neat sketch I will write and explain. Now come to option 2. See, I will put bigger here. Option 2. Very, very important. Because you write here. Very important. Because reason. Now onwards, whenever we get this, I am telling 10th time today, inclined planes in friction chapter, and if there is only one inclined plane, we will consider xx along the plane and yy perpendicular to the plane. See, advantage you cannot make out now. Later you can make out. Maybe later in one question, I will show you advantage of this one. Later. Okay. Reference axis xx, yy, xx along the inclined plane. See here. Xx along the inclined plane and yy perpendicular or normal to the inclined plane. See, therefore your yy will pass through R and xx will pass through ff. So remember now, so for ff there is no resolution. Why? It is directly along xx. For R also there is no resolution because it is directly along yy. But W is vertical. Reference is not horizontal vertical. So for W, see now, consider the angle with xx, not with horizontal. You consider the angle with xx. That is, for W, see here, this is theta. When this is theta, see here, this will become 90 minus theta. That is common sense. Okay. So 90 minus theta is angle made by W with xx. Remember, consider angle with xx, then what happens? X component is cos and y component is sin. Be careful. X is cos, Y is sin when you consider the angle with the XX. If you consider the angle with YY, then Y becomes cos, X becomes sin. Don't do it. In my class I told we will stick to one principle, if you remember. If XX, YY are horizontal and vertical, we will always consider angle with horizontal, that is XX. Then horizontal is cos, vertical is sin. If XX and YY are inclined, again we will consider angle with the XX. So X becomes cos, Y becomes sin. So here see, this W has got component. See, this force has got little down, I will write here because space problem. Okay, W, okay. W. If you resolve this W now, see, this way and this way, see, one component like this, see, or I don't think, I'll put angle 90 minus theta here, space problem, okay, little bigger I'll write, okay, to make more clear, little bigger, okay, that the space problem is not there, okay, W. Now, see, this is your 90 minus theta, it will clear. Theta. Now, if you resolve this one, see, along XX, it is component is like this, and along YY, its component is like this. This is sin, this is cos. Y along XX, cos, along sin, but both sin and cos with respect to 90 minus theta. Sin and cos of the angle made with the XX. Okay. This all I told long back once, engineering mechanics, and one class little 2 class earlier, exclusively I told. So this much I need not tell. You can observe one thing today. I decided to change my speed. I decided to talk little slowly so that very crystal clear understanding is there. Okay, start now. Therefore, anything else? No, nothing. See, first as usual, make sigma Fy0. Fy0, not upward positive. See, this is positive. We will take this is positive. Your choice. That is, see, this positive. You get plus, see, no resolution, plus R, then this, see, this is purely along XX, it will not come, plus R, this has only X component, pure Y, this is purely X, purely Y, this is inclined, so plus R minus W into, since you are doing Y component, it is sine of the angle made by W with the x-axis 90 minus theta. 90 minus theta equal to 0, or you get R minus W sine 90 minus theta is cos theta equal to 0. Therefore, your R will come W cos theta. Okay. One answer. Equation number 1. Okay, now make sigma fx0. See, we will take right, see, we will take this is positive y, this will make positive x. This is positive y, see, sigma fx0, this side positive. So, plus mu r, this has no component, minus, see, minus w into x component is cos of 90 minus theta equal to 0. 1 minute. Again, doubt about the board. Sometime I get the doubt. Okay, no problem. Bear with me for those things all. This all will, I can eliminate if I put a camera and some electronic board. Okay, then, or, therefore, see, here, now, what you do is substitute R equal to W cos theta, that is from 1. Then, therefore, you get mu into R. R is W cos theta. See, you already got R W cos theta minus W into cos 90 minus theta is sin theta equal to 0. W will cancel, or you will get mu cos theta equal to sin theta, or sin theta by cos theta. Sin theta by cos theta equal to mu, but we know that sin theta by cos theta is tan theta. Tan theta equal to mu. This is a result actually, that is, or you can tell theta equal to tan inverse mu. I told, yes, see, we got it here. Theta equal tan inverse mu. So by both the approaches, we got theta equal tan inverse mu. Now be careful, some statements are there. Okay, everything I will remove now. See, whether you consider x horizontal, y vertical, option 1, or x along the plane, y perpendicular or normal to the plane, whatever you do, finally you got theta is tan inverse mu. Okay. Now common continuation. See, now what you are doing is common continuation. See, now right here. Now, see, common continuation. Common continuation for both option 1 and option 2. Option 1 and option 2. Of course, option 2 is the most important. Okay. We got theta equal to tan inverse mu. Tan inverse mu. Now, we know that you should know it. We know that mu equal to tan phi. I already tan phi. This already I told you, where phi is called angle of friction. This I told you earlier, you forgot it. Remember it now. Angle of friction. Therefore, theta equal to mu equal to tan inverse phi, or phi mu equal to what? Tan inverse phi. Therefore, theta equal to tan inverse of mu is what? Tan phi. Tan inverse of tan phi means, therefore, theta equal to phi. Very, very important result. Theta equal to phi. You can do some other way. Or see, if people get confusion is there, you do one thing. Earlier we got, don't write this way. Earlier we got what? Tan theta equal to mu. Don't put inverse. See, earlier from the solution we got tan theta mu. But we know that tan phi also is mu. See, this we got by analysis. This is standard. Tan theta equal to mu, tan phi equal to mu. Therefore, you can tell theta equal to phi. Both are same language. Okay, now, therefore, I will conclude now. See, therefore, see, conclusion. Therefore, when a body is freely placed on an rough inclined, on a rough, if rough is not there, okay, on a rough inclined plane, the body will be on the verge of sliding down when angle of inclination of inclined plane with that is your theta, is equal to angle of friction, that is phi. And note, mu equal to tan phi. Okay, tan phi. Therefore, now in the class I will explain something. You should write it. See, just imagine for this contact surface, angle of friction is anything, say I told 21.6 degrees. Okay, then if the angle is less than 21.6, the body will be in stable equilibrium condition, it will not slide. When the angle reaches 21.6 degrees, that is when the angle of inclination of an inclined plane reaches the angle of friction, the body is on the verge of sliding down. Or 21.6 I told for understanding, or you write here. Therefore, if a body is freely placed on a rough inclined plane, and if the angle of inclined plane is slowly increased, a stage will come when the angle of inclination of the inclined plane exactly becomes equal to the angle of friction phi. At that particular angle, the body will be on the verge of sliding down. A little more angle means it will slide down. Or this angle of friction phi is the maximum angle up to which maximum angle of inclination of inclined plane up to which if a body is freely placed on the inclined plane, the body will not slide. It will be in equilibrium or stable state. Nothing will happen. Maximum angle is phi. Now something else is there. Or see, now one more thing, class. This theory we can use to experimentally find coefficient of friction mu. See, I will tell you how now. See, once again I will tell 21.6 degrees. Okay, 1 minute. See now. If you want to see coefficient of friction, you cannot see it. It is only imagination. So, if you want to find, see, between two contact surfaces, if you want to find the coefficient of friction, what you do, what all I am telling you should write. If you want to experimentally find the coefficient of friction, what to do? Place this way, horizontal. Nothing will happen. Okay, then slowly increase the angle. Very slowly. Suddenly you can see at a particular angle, the body is on the verge of sliding down. See? Started. Find that angle. That angle is theta. Okay. Then that theta equal to phi. Then tan phi will give mu. So tan of that angle will give coefficient of friction. Okay. Now, in the title you can see today's class, important concept of inclined plane, and related to one word I will use here. See, I will tell one word there. Something related to, see, soil mechanics. Angle of repose. This is a very popular in soil mechanics. See now, Symbol is once again phi there. I will tell what is that angle. See, suppose you pour the soil. See, if you have a surface here, you pour the soil on surface. What will happen? The soil will rest something like this way, correct? This is the soil. Now, this is the angle that is phi, up to which it is stable. If you put further more soil here, it will start sliding down. So, that angle of repose in soil, you should write all these things. Angle of repose we refer in soil mechanics is the angle made by that inclined plane. See what way it rests with horizontal. When, see, that is stability counts now. So if the angle is, this angle is less than phi, the soil will remain as it is. If you put further steep, see, suppose you know that one. Suppose you put soil this way, what will happen? No, it will slide down and settle like this. How? It will settle for angle phi. See, for example, suppose, see, this is the phi for stability. Suppose by chance you take container of this way container and fill with the soil. Remove the outside container. Suddenly, this angle is more than phi means soil will start coming down. It will settle this way. See here, it will settle this way. That is, it will settle for that angle phi. So therefore, when you pour soil, up to what angle, it will freely, see that inclination of the angle, that inclination of the inclined surface of the soil with the horizontal, we call, further I am not telling because this is not our soil mechanics, angle of repose. Now, if it is, see, suppose you consider boulders or what, size stones, etc., then you can make out it will stand for higher angle, because angle of repose is more. Suppose you take ordinary soil, see, it may settle like this. Suppose you take sand, it is more finer, then it will settle like this only, see, this only, sand. The angle will reduce. That is, as the material becomes finer and finer, the angle of repose will become lesser. This phi is very important because when you find lateral earth pressure, see, 1 minus sin phi divided by 1 plus sin phi into density of soil into height x from the top, that will give the lateral pressure. That all I will not tell here. So this angle of repose. And now a question will come. See, in the soil mechanics, you write lateral pressure equal to pressure P equal to 1 minus sin phi by 1 plus sin phi into density W, weight density, or rho I will put, okay. Rho means weight density. I usually use rho. Weight density into height h from top. This is the formula for pressure. But in case of water, this is for soil mechanics. For water, you take what? Pressure equal to simply rho into h. You don't consider this term. Tell why? Because for water, your phi equal to 0 degrees. See, suppose you have a surface here, pour water. Water will not stand like this. Water will not stand like that. When you put water, it will rest like this only, see. When you pour water on a surface, horizontal surface, water cannot stand like this. It will become flat. So for water, your phi equal to 0 degrees. When phi is 0 degrees, see, 1 minus sin 0 divided by 1 plus sin 0. Sin 0 is 0, sin 0 is 0 equal to 1, or this term will become 1. Therefore, lateral pressure for water is maximum, whereas for soil or anything else, it will reduce. See, this number is always less than 1. See, you may be knowing in soil mechanics, the very popular phi is 30 degrees. Then this will come 1 by 3. 1 by 3. That is, if the water pressure for a particular height is how much? 30 kilonewton per meter square, soil pressure will be only 10 kilonewton per meter square. As it becomes more and more finer, as phi decreases, pressure will increase. As phi decreases, see, pressure will increase. Here see, 1 minus sin 30 by 1 plus sin 30 will become 1 by 3. You know it, that answer. Okay, this is, and now in engineering mechanics, you make a last note. So many people, I don't agree with them. See, first of all, this statement, I don't agree. When an inclined plane, if you freely write, you write note, whatever I tell you right now, if you place a weight on an inclined plane, rough inclined plane, at what angle the body is on the verge of sliding, that angle, so many people call it as angle of repose. But actually I don't agree. Angle of repose, I think, comes in soil mechanics. But okay, so many people, they write it. So in friction chapter, if they ask angle of repose for an inclined plane, you write it is the angle at which a body freely placed on the inclined plane is on the verge of sliding down. Okay. This will conclude the theory part today. Study everything, understand. Now we will do problems. Okay. Thank you. We'll meet in the next class. Anything else required? A long exercise? No, nothing. I told experimentally how to find out. Okay. Everything is over. By chance, if I feel something else is to be told, next class I will tell it.